All right, so starting on to the next one here. A ladder leans against a building. Top of the ladder touches the building 10 feet above. That is not a highlighter. 10 feet above the ground. The foot of the ladder is 4 feet from the building. Find the angle that the ladder makes with the ground. And we want nearest degree here. So draw a picture if it's not given to you. So we have a building. 10 feet above the ground. We have the ladder leaning away. So this is 10. It's 4 feet from the base of the building. We want to know the angle, nearest degree, the angle the ladder makes with the ground. So that's going to be, remember that the ladder is essentially right here. All right. So the angle we're looking for is going to be down here. Now, once again, right triangle, because it's a building straight up and down. And whenever we're looking for an angle or using an angle, that's going to be our Sohcahtoa. So we find our angle, label our sides. We have opposite and then adjacent. So we're going to use tangent. And we're going to do tangent of the angle, which we can call x, is equal to the opposite 10 over the adjacent 4. Remember, to get rid of the tangent, we're going to use the tangent inverse. Okay. And then we're going to take our calculator here. We're going to go to trig. We'll make sure we're in degree mode. We're going to use tangent inverse. And then we're going to enter our fraction 10 over 4. And then we're going to round to the nearest degree. So that's going to be 68 degrees. All right. Same thing with 406. Handicapped access ramp to the building. Code states for 1 inch in vertical rise. The ramp must extend by 12 inches. The angle of inclination is kind of like the angle of elevation. So we're always putting that, if you remember, in the bottom corner here. All right. And they've called it X for us. So once again, right triangle, we're using an angle. We're going to use trig. So we label the sides. We have opposite and adjacent again. Still sticking with tangent. So the tangent of the angle is equal to the opposite one over the adjacent 12. And then we're going to use the inverse, okay, to solve. And we're going to get x is equal to, we're going to go once again, trig, tangent inverse, our fraction, and then we're going to round to the nearest hundredth of a degree. So that's 4.76. And that's it. And these are officially degrees, so we might as well label them accordingly. All right. Okay. Maybe we'll label them accordingly. And out of this. All right, we're back. Okay, 409, in a right triangle. Hypotenuse, ABC. So the hypotenuse is ABC. So that means that the right angle has to be C, since the hypotenuse is AB. So we can draw a picture. Right angle, C, hypotenuse AB. Doesn't necessarily matter which is which. Its side BC has a length of 17.6. All right, and the hypotenuse is 26. We want to find the measure of angle B to the nearest degree. So we're going to, once again, right triangle, angle. We're going to pull out our Sohcahtoa. All right, we're going to label our sides. So we have adjacent and hypotenuse. The opposite side, which is across, we are not using. So if we're using adjacent hypotenuse, we're going to use cosine. So the cosine of the angle, which we can call B if we want, is equal to adjacent 17.6 over the hypotenuse. And then we're going to use the cosine inverse to undo the cosine here, leaving us with B. And then the cosine inverse of 17.6. All right. We're going to go trig, cosine inverse. And then we're going to type in our fraction. So when again, that's 17.6 over 26. Hit enter. and we'll have our answer rounded to the nearest degree. So that's going to be 47 degrees. And we have our answer. Okay, on to the next one. A man who is 5 foot 9 inches tall cast a shadow 8 feet 6 inches long. Assuming the man is standing on perpendicular ground, what is the angle of elevation from the end of the shadow to the top of the man's head to the nearest degree? So because we're dealing with inches and feet, we're going to have to pick one. Okay, I think it's probably easier to deal with inches rather than feet. So 5 feet 9 inches is 5 times 12 and then plus 9. So that's 69 inches. And 8 feet 6 inches is 8 times 12 plus that 6. So we take our calculator if we want. We can do 8 times 12, which is 96. Oh, wrong button there. And then plus 6 is going to equal 102 inches. So we can draw ourselves a little picture. So we have a man. Well, we might as well get official with it, right? We have a man standing who's got a shadow here. He is 69 inches tall, and he is leaving a shadow out here. That is 102 inches. We want to know the angle that the 10th degree of the shadow, from the shadow to the top of the man's head. The end of the shadow, which is right here, to the top of the man's head. So it's asking for this angle again. Okay, what is the angle of elevation? So that's how we know we're down here. All right. Once again, because we are talking about an angle measure, which we can call x, we are going to use opposite and adjacent and pick out our trig function, which again is going to be tangent. So the tangent of my angle is equal to the opposite over the adjacent. And then we're going to use the tangent inverse to solve. So x is equal to, we're going to hit trig, go to tangent inverse, type in our fraction, 102 though, not 120, and we're going to get 34.1. All right, and that is our answer. Okay. Let's go down to the next one here. Kayla was cutting right triangles from wood to use in an art project. The right triangles are shown below. We know that the triangles are similar, which is important. Remember, similar means that their sides are proportional. All right, and more importantly, the angles are congruent. So if the right angles are B and E, it gives you BC and AC is 17. They want to know what is the measure of angle F. Remember, because the angles are equal, angle F is the same as angle C. So if I can find C, I'll know angle F, okay? So because we're dealing with a right triangle with a side, we're going to label our sides and use our Sohcahtoa. So we have adjacent and hypotenuse again. So Sohcahtoa. All right, and because we have adjacent hypotenuse, we're picking cosine. So the cosine of our angle C is equal to the adjacent, which is 15, over the hypotenuse, which is 17. And then we're doing the cosine inverse of cosine C is equal to the cosine inverse of 15 over 17. And then C is going to equal, we're going to go ahead and do once again trig, cosine inverse 15 over 17, hit enter. And we'll have our answer here, which is 34 degrees. Took me a minute there to realize I never hit enter on the calculator, and we were looking at the last answer. So this one should be 28 degrees. So choice number 1. I realized that wasn't showing up as one of the choices. Degrees. And there is our choice. Okay, the next question was a little bit more difficult on the exam. It's not incredibly difficult, but we want to figure out, we have a movie projector, okay, onto a large outdoor screen, the bottom of the 60-foot tall screen. is 12 feet off the ground. The projector sits at a horizontal distance of 15 feet from the screen. We want to know what is the measure of angle theta to the nearest tenth of a degree. So what we need to remember here is anytime they're giving us any of these lines drawn through the middle of a triangle, is that they're giving us two separate right triangles. And that's exactly what's going on here. Okay? So what is happening is, in order to figure out the measure of theta, we need to treat these triangles as two separate things. Okay? And if we can figure out the measure of this angle right here, and then the measure of the entire angle, we can subtract those to get theta. To do that, we're going to need to count this whole screen from top all the way to the ground, okay, as one segment. So that's 72. And then the distance between the ground and the bottom of the screen here is 12. That's going to be our other triangle. So once again, because we're dealing with right triangles, okay, we have one right triangle here that has sides of 75 and 12. And we're looking for the angle down here, which we can call x. So since we're dealing with a right triangle and an angle, we're going to use Sohcahtoa. We have the adjacent side and the opposite. So that tells me we're going to do tangent. So the tangent of, we'll call it x, is equal to opposite 12 or the adjacent 75. And then I'm going to do my tangent inverse of tangent x, and then the tangent inverse of 12 over 75. And so x is going to equal, we go to trig, we pick tangent inverse, 12. Oh, we didn't pick tangent inverse apparently. We need to clear this. I think we hit undo an accident. Tangent inverse, 12 over 75. And we are going to get 9.09. We'll say 092 or 0939.09, right? Yeah, 03. Okay, and on the second triangle, that's the really big triangle. We have sides of 72 and still the same distance across here, which is 75. And so if we're looking for this angle, which we can call y here, we're going to do the same thing because we have opposite and adjacent still for the side lengths. So the tangent of the angle is equal to the opposite side, 75, over the adjacent. Whoa, time out. Whoa, did you see what we did? We call this adjacent when this is supposed to be opposite. We call this as opposite when this is supposed to be adjacent. So it should be 72 over 75. And then once again, we're going to use our tangent inverse of tangent y, and the tangent inverse of 72 over 75 is going to give us our angle measure. So tangent inverse, 72 over 75, it's 43.80309. That's 830. And then, to get theta, we're just going to head and subtract. All right? So, theta is equal to 43.8309 minus 9.0903. You want to at least go 3 or 4 decimal places, but remember, when we do the actual subtraction, on our calculator, we're going to use the decimal. We're going to press the up arrow to highlight the decimal and do the subtraction using the entire decimal here. So we get 34 point, and it says nearest tenth, so that's 34.7 degrees. Okay? 34.7 degrees. And that is our answer. All right. Now, these next questions get a little bit tougher, okay? So in this first question, let's get rid of this one. Once again, remember we talked about there we go. And the diagram below shows the plans for a cell phone tower Now the guy wire is like the wire that's attached to the top of the pole that kind of holds a pole in place, prevents it from falling over, to makes an angle of 65 degrees with the ground. From the point of the ground, 100 feet from the end of the guy wire, the angle of elevation to the top of the tower is 32 degrees. Find the height of the tower to the nearest foot. Now, what we want to do is remember that they're cutting a line through our right triangle here. So they're essentially giving us two separate, right triangles. My job is to figure out what this tower is, all right? The height of the tower. Now, what I really need to do is figure out what this side is, in order to make that happen. And if I do that, this whole side gets a measure of 100 plus x. And so what happens is, here, if I set up, once again, we're using angles and right triangles, so we know we're going to use Sohcahtoa. We can call the tower T if you want. And so if I do opposite and adjacent, for my triangles here, and we can kind of redraw this for ourselves. All right, so opposite and adjacent, we're going to do tangent. So the tangent of 65 is equal to the opposite t over x. And so if we cross multiply, we're going to get x times the tangent of 65 is equal to t. Likewise, when we look at the other triangle, the big triangle, we're still going to be using opposite and adjacent here, but we're using the 32 degree angle. So the tangent of 32 is equal to the opposite, which is t, and this time it's over 100 plus x. So if we cross multiply again, we're going to get 100 plus x times the tangent of 32 is equal to t. And since these equations are both equal to t, we can then set these two things equal to each other. And I will show you a different way to do this in a second, But for right now, this is the way that you would use it using Sohcahtoa. So if I said x times the tangent of 65 is equal to 100 plus x times the tangent of 32, all right, what we can essentially do is just solve for x. So if we distribute through, we're going to get x times the tangent of 65 is equal to the tangent of 32 times 100. We'll write 100 tangent 32 instead. It's going to be a decimal. I'm going to leave it like this because it's more exact. Plus x times the tangent of 32. Now what I want to do is I want to get all the x's on one side, and then I'm going to factor out the x. So I'm going to move the x tangent of 32 to the other side. All right, so I'm going to subtract. So I'm going to get x, oops, I forgot the x here. X times the tangent of 65 minus x times the tangent of 32 is equal to 100 times the tangent of 32. Now we can undistribute the x to get this. And then I can just divide both sides by what I just is in the parentheses there. So the tangent of 65 minus the tangent of 32. And this will give me the value of x. All right, so x is going to equal, and we're not done yet. We're almost done, So 100, so we're going to do control divide for a fraction, times trig tangent 32 over tangent of 65 minus the tangent of 32. And we get that decimal right there. So 41.0 or 1196. Okay, so that's the value of x. So when we want to figure out the tower, remember we have this expression right here, and we cross multiplied. So the tower is just equal to 41.1196 times the tangent of 65. And so the tower is equal to, and remember, we're going to take the whole decimal and just multiply it times trig tangent 65. And we get 88 to the nearest foot is 88 feet. That is the height of our tower. Okay, now let's go do it a different way. So we have another tool at our disposal called the law of sines. All right, and we went over this in the beginning of the year. Now we know that we have a triangle drawn here with angles of 65 and 32. All right. We have a side here of 100. And we want to know the height of the tower here. Now, what we really want to do for this question is actually just figure out this side in the triangle. And what we're going to do is we're going to use this non-right triangle first. And so if you remember this law of sines, okay, let's just give these letters. We'll call this A, B, C. So the law of sines says, okay, side A, which is across from angle A, so that would be this side, over the sine of A, the angle A, is equal to side B over the side of angle B. Now B is across from angle B, so that would be the 100, is equal to side C over the sine of angle C. So think about it. We know what this angle is, or this side is. So in order to use this side, we actually need to figure out this angle. Because we are going to use this side, right? This A, we have the 32. If we want to use the 100, we need the angle across. We can get it because we have the angle that's 65. And so right next door to it has to be a 100. It has to equal 180 with the 65. So this is going to be 115, which means angle B, if I add it to 32 and 115, is going to give us 147. So 180 minus 147 is going to equal 33 degrees. That's the measure of this. Also 33 plus 32 is 65. That's our exterior angle theorem. And now I can use my law of sines to do sine of A, or A, which we don't know, over the sine of A, which is the sine of 32, is equal to B, which is 33. Nope, that is not. That's the angle, not the side length. 100 over the sine of 33, and then I can cross multiply and solve. So A sine of 33 is equal to 100 times the sine of 32. I divide out by the sine of 33, and I'm going to get A to equal, and we're going to do control divide for our fraction bar here, 100 times the sine of 32, so trig sine 32, over trig sine of 33 is 97.2973. All right, that is the length of A. So if we're looking for the measure of T, now we just have to use this smaller triangle here. We know that this is 65. We're trying to find T, and we know this is 97.2973. So we have, in our triangles, a right triangle with an angle. We have the opposite side and the hypotenuse. So we're going to do the sine of 65 is equal to the opposite over the hypotenuse. And we're just going to cross multiply. We're going to get T is equal to 97.2973 times the sine of 65. And we're going to use a calculator for that. Remember, we're going to copy down that line we got earlier. We're going to go trig, sine, and once again, we're using 65 here. And notice that we get the exact same thing that we got earlier for our answer. So this is just another way to do this, using the law of sines to get this side, and then using Sohcahtoa to find the measure of the angle. All right, so when we get down to this question down here, oh, this is the last one. This is congruent triangles. When we get to any other questions that are on this one, we're going to use the law of sines moving forward. But I just wanted to show you both. So using Sohcahtoa for both and getting an expression, solving for x, and then evaluating for t, or using the law of sines, it gets a little bit easier to do. But if you don't remember the law of sines, that's how you can do that one. All right, last question of the day here. A homeowner is building 3 steps leading to a deck, as modeled by the diagram below. All 3 steps, H, A, F, G, and D, E, are congruent. All 3 steps, H, G, F, E, and D, C, are congruent. Each step rise is perpendicular to the step run it joins. The measure of CAB is 36 and CBA is 90. A lot of stuff going on here. All right. If each step run is parallel to AB, it has a length of 10 inches. All right. So once again, rise over run. So each run is 10 inches. Okay. Determine and state the length of each step rise to the nearest tenth of an inch. So a few things we know. We know, okay, that the step runs are congruent and the step rises are congruent. That's important, okay? So they give us the measure of CAB, which is 36. So far, so good. And CBA is 90. Now, if these are all congruent, that means all the runs are going to be 10. And so this bottom side, it has to be 30. Now, they want to know to determine the state of the length of each step rise nearest tenth of an inch. So what we're going to do is do one of two ways. We can find the length of CB here, which we can call x first, and then just divide it by 3. Or if you remember that since these are parallel, this is also 36. And then we could use Sohcahtoa on this smaller triangle. And then you'll know the answer right away. So just show you that it's both are the same. We'll do the big one here. So we're going to, once again, we're dealing with a right triangle. We're dealing with an angle measure. So we're going to label our sides. We have opposite and adjacent. So we're going to do tangent. The angle is equal to the opposite x over 30. We're going to cross multiply to get 30 times the tangent of 36 is equal to x. And then we're going to grab our calculator, do 30. Well, after we get down here, 30 trig, choose tangent, 36. And we're going to get 21 point, the nearest inch. We'll do 21.7963 is x. So because that is the length of x, we're just going to divide that number by 3 and then round accordingly. It does say to the nearest inch, so that's going to be 7 inches. And if we, careful, because we rounded this to 22 when we divided, I think we still would get 7 if we divided it by 22. We still would get, why did I divide by 7? And if you put a decimal point, by the way, after your number, to give you the decimal answer. We'll still get 7, so it'll still work. All right. Now, if you treated the small triangle here, and we want to know opposite and adjacent, right? We could do the tangent of 36 is equal to, let's say, y over 10, and then cross multiply. So 10 times the tangent of 36 is equal to y. 10 trig tangent 30. 36, and notice that we're going to get the same thing what you did up here, okay? And so the length of, oh, do you see that we did this wrong? Man, it says find the length of AC. Oh, it says both, so the step rise. So the length of the step rise is 7 inches, right? But we also need the length of AC. That's the second part. So remember that if now we want to determine this length, because this is kind of like a two-part question, all right? We want to find this. So we'll call this, we used X, we used Y. How about Z, okay? We are using the adjacent and now the hypotenuse. So we're going to do cosine of 36 is equal to the opposite, or the adjacent, which is 30, over the hypotenuse, which is z. Sorry for the back and forth there. Cross multiply, we're going to get z times the cosine of 36 is equal to 30. And then we can divide by the cosine of 36 from both sides. And we'll get z is equal to 30. Trig. Cosine. 36. 37 to the nearest, what are we at? Inch. So it's going to be 37 inches. Okay? So the length of each step rise is 7 inches, and the length of AC is 37 inches. All right, hopefully that helps. If you guys have any other questions, let me know. But hopefully you guys have a great weekend, and we'll see you on Monday. 2 days left, guys. 2 days left, everybody.